All right, so now we are going to graph in this form. And I've told you before that it's vertex form. This is vertex form. And we're going to learn how to graph in it today. So the first one is put them in your calculator. So x squared, we've learned from last time, my numbers for x squared are this. I'm going to graph my same x squared parabola that we graphed in the last lesson. Maybe now you can see that my axis of symmetry is happening right here. This is my axis of symmetry because these numbers are the same and these numbers are the same. So they are reflecting across that axis of symmetry. That's what that means when we said that every point reflects. You can do that to help you graph. So then I want you to pause the video for a minute and I want you to take some time and plug in these numbers. So you would do 0, let me put it down here. So this one would be 0 minus 2 squared. This would be 1 minus 2 squared. This would be 2 minus 2 squared. This would be 3 minus 2 squared. Does that make sense what we're doing? So I want you to pause the video and I want you to put that in your calculator. You can also use the table function that we talked about last time. That is going to give us 4, 1, 0. Hey, those are the same numbers as before. So when x is 0, my graph is, or my y is 4. When x is 1, 1, and the 2 is at 0, the 3 is at 1, the 4, there we go. So that moved it. It says minus 2, but it did not move it to the left. That's interesting. Let's try this one. So we are going to start with our same parabola that we had before. So we have our middle one. See how I can draw those points as reflecting across the axis of symmetry? It does help me graph a little bit faster. So what I want you to do, this is one of the many typos that I told you there. We're not going to use these numbers. Instead, I want you to use the numbers -3, -2, -1, 0, and 1. So when we plug this one into our calculator, we would do -3 plus 1 squared, -2 plus 1 squared, -1 plus 1 squared, 0 plus 1 squared, and 1 plus 1 squared. Again, pause the video, take a minute to plug it in, or use your table to find values. After you're done, unpause the video, and here we are. Hey, we have new numbers. So at -3, I'm up at 4. At -2, I'm at 1. At -1, I'm at 0. 0, 1. So this time, our answer said plus, but it moved to the left. So what can we do with that information? Well, when an equation is in this vertex form and there's a minus sign in between the x and the h, the graph is shifted to the right h units. That's just whatever the units of that is. When we graph the equation x plus h squared, the graph, when it's plus, it goes to the left 8h units. Okay? We are going to learn this thing that we're going to keep using, but insiders lie. Because of the formula that we're going to learn in just a minute, and because of the parentheses, things go in the opposite way. So when I graph each function, all right, so we know that we're going to add 4, but we're going to do we're going to move to the left. So I'm going to take my normal table of values, this -2, -1, 0, 1, 2, and I need to change my x numbers. So I'm changing these numbers to the left. I'm going to -4. So -2 that was up there minus 4 is -6, -5, -4, -3, -2. And then you need to plug in your thing where I'm plugging in this value. So -6 plus 4 squared. and get a value. -5 plus 4 squared, -4 plus 4 squared, -3 plus 4 squared, -2 plus 4 squared. And you will find that your graph moves from the x squared, and you can go back to your x squared graph and look at those points and move them all 4 to the left. So if we look at this blue graph and the purple graph that we did here, you can see that all 5 of those purple graph points are moved to the left. So let's see if I can use that same information to graph this -6. So he's going to go to the right. So I come up to my purple graph. See those purple points? I'm going to move all of them 6 to the right. So the 0, 0 will move 1, 2, 3, 4, 5, 6 to the right. My point that was here will move 6 to the right. And then my points that were up here will move 6 to the right, and we end up having this. You can also put it in to get your table, to get that information. So there has to be an easier way to do this, right? Like this is time consuming and plugging it in the table and always having to graph an x squared and left and right and all of that. So what we're going to learn about is the vertex form of a quadratic equation. So in order to graph any quadratic, we need at least 3 points. But we always want 5 because it helps us make accurate graphs. We can easily find the points if we have 2 things, the vertex, which we learned about last time, and the growth rate, which we learned about last time. Vertex form is y equals a x minus h squared plus k. You already know from last time's lesson that a is our growth rate. It's going to turn it upside down. It's going to make your graph fat and skinny. It's going to do all of that. Then h and k are our vertex. And our vertex is always written in the form h comma k. That insider's lie. H is the opposite sign. So h will always be the opposite sign. Okay, so we can always use the table to graph, but it's clunky and it's time consuming, and I know you guys want a shortcut, so I'm going to teach you the shortcut. So we know 4, 1, 0, 1, 4. That's our really easy pattern. So I want you to look at this. How far apart are these two numbers? From 0 to 1, how far apart are those y numbers? Well, they are 1 apart. How far apart are the 1 and 4? They are 3 apart. Okay, so our growth pattern is always 1 times A, 3 times A. If we kept going, it would be 5 times A, 7 times A, 9 times A. But those points usually get us what we need to graph. So, Miss Stone, what does that mean? Well, I am going to show you, and you are going to be, I think you're going to like it. So, we're going to find our vertex first. This is our x and y of our vertex, but our x is the different sign. So it's going to be positive 3, positive 1. My growth rate, I get what that number is. It's invisible. Okay, so I'm going to graph my vertex at 3, 1. That's my vertex. That means my axis of symmetry is right in the middle. Okay? Now, before I even go any further, I can actually, if it asks me, because it's going to on your homework, I can actually find increasing and decreasing because I know this parabola goes like this. So I'm going to increase on the right side of my vertex from 3 to infinity. And I'm going to decrease on the left side of my vertex. Oops, nope, negative infinity is less. Negative infinity to 3. Why did I put a negative 3? Increasing and decreasing, my axis of symmetry. I'm going to label it as x equals 3. We got them all there. So then the last thing I'm going to do is 1a, 3a, 5a. This is what I need to graph. All right, so we know that our growth rate is 1. 1 times 1 is 1. 3 times 1 is 3. 5 times 1 is 5. So what does that mean? What can I do with this information? Well, I always go over 1 up, and then I'm going to go 1A, and then I go over 1 up 3A. It might seem really confusing, but here's what I go. I go to my vertex. Here I am at my vertex. I'm going to go over 1. It doesn't matter, left or right. I'm going to go left first. Over 1. Up 1A. 1A is 1, so I go up 1. Then I go over 1 the other direction and up 1. Now I don't go back to my vertex. I stay at my point, so I'm right here. I'm going to go over 1 and up 1, 2, 3, because my A was 3. Then I'm going to go back to this point over here and go left 1 and up 1, 2, 3. And I have my parabola all drawn without having to do the thing. I'm going to do one more for you in this video, and then you can catch me, or we can do video number 3. So opposite of this and that, so my vertex will be -2, 5. I'm going to go mark that point. It's right here. My growth rate is -1/2. So we're not going to worry about increasing and decreasing this time. I am going to mark my axis of symmetry at x equals -2. So my 1A point is going to be 1 times -1/2, which is -1/2. 3 is going to be 3 times -1/2. This is -3/2. 5 is going to be -1/2 times 5, so -5/2. So here's what happens from my vertex. I'm going to go over 1 and down 1/2. Then I'm going to go over 1 and down 1/2, 2/2, 3/2, and mirror that point over here. If I want to keep going, I can go over 1 and down 1, 2, 3, 4, 5/2. I'm going to connect all those dots like that. And that's your basic introduction to intercept form. So we are going to do that. I will get you the lesson video number 3. We'll have the last part of this lesson. I'll talk to you in a minute.